All right. Good morning, everyone. Let's get started with today's class. So today the idea is for us to finish that script that we were working with. If you recall, that was we were wrangling the USDA NASS soybean production data for Georgia over time at the county level. So what I want to ask you to do is, let me just close a few windows here. What I want to ask you to do is to, if you don't have yet, launch that RStudio project. So right now I'm browsing into my folder for the course. You know, if you are doing that and you are in your main folder of this course, you should have the 03 NASS project folder. If you go inside of it, there is the rproj icon. And I just want, I will be emphasizing this point probably for within the next projects that we do. But just to remind you, to make sure that files work well, especially when you are importing or exporting into an RStudio project, you do want to make sure you are in that project, right? So if you just have a random RStudio environment window open that's not this project, I would propose that instead of using that, you come here and you click on that 03 NASS rproj and launch this project, because that's going to help you keep your files in the right place and also avoid potential issues with importing files. So I just did that. I see here you want to see the 03 NASS name on your top right. That means you are in the right project. And you may already have pop up the script that we were working with. So that script for me already opened up. I'm going to minimize the console here just so I have more space. If you recall, this was the 0124 NASS summary partial.qmd for Quarto, is a Quarto file. Again, as another refresher, if you open the correct project, you can come on the Files tab and see things here, right? So for me, it is showing what's inside the code folder. So I have one more script at this point that you don't have yet. So you may be seeing just your 0124 NASS summary partial. You may be somewhere else within this project, and to navigate there, you would click on the R blue button to take you to the main folder of this project, and then you can browse the files there. So if you're not seeing your script up here pop up, you would click on that R blue button under the Files tab, navigate to the code folder, and then click on that script to launch it on the left side. So this is where we left off last time. We made this, or maybe not here. Let's navigate down to where we stopped. Okay, so this is where we stopped. If you notice, I yet don't have anything in my environment. That is by design, because we ask R to not save our objects if we close that R window. If you still had your RStudio window here opened and you still have your objects, that's fine. You can just keep working. In my case, if I try to run anything at this point, it's going to give me an error because I have not yet loaded my packages. I have not yet imported the data that we're using. So it really, it needs that context. If you are like me, where your environment is empty, I would, so here on this outline, you can toggle that on and off. On this outline here, you just go back to the beginning of the script. Make sure you run the chunk with where we load the packages. And also, just another reminder here, always remember that install.packages, we run once and we don't run that again. So in my case here, I deactivated that code of the install packages by adding a comment in front of it. So R ignores it. If you forgot to do that and you played the whole chunk, it's probably installing again for you, which first off, it takes time, especially with tidyverse, and also it's not necessary. So make sure if you have install.packages functions within your script, just make sure you make them active the time to install, but then either delete that line of code or make it inactive by adding a hashtag in front of it. Okay, so we have to play this first chunk here that loads our packages, so now the functions we need are available to us. We also need to, if you are like me and your environment is empty, we also have to run this chunk here to import that soy object that we already have developed the code for last time. You don't really have to worry about the next few chunks because they're just looking at that object, but they're not really creating any objects, any new objects. So we're just exploring that. The next one you would have to run is the soy W chunk, because we are creating that soy W object, which is the one that we use afterwards. So go ahead and run that as well. You should be seeing the soy W on your right-hand side environment panel. And you can just keep going lower on your code, because from that point on, we were just exploring things. We did not create any new objects here. The point that we stopped was this question: what was the lowest production in 2022? If we play that, now when you play that, it should work. Okay, was everyone able to get to this point here? If you were not, please let me know. I'm gonna give you 30 seconds here in case you need them.
I get an error.
Rolando, did you say something?
Yeah, I got an error. Let me
What is that? What does it say?
So what was the lowest production in 2022? When I run it, said object soy not found. So
Okay.
I guess I need to go back.
So if it's telling you that object does not exist, it means that you did not run the chunk that produces that object, right? So we just did that. If you go back here on your outline on that soy underscore W chunk name, this is where we created soy W. So you have to run this chunk to have that available for you.
Got it.
Yeah, so now if you go to that chunk that we were, what was let's see. What was the highest? Production over time, what was the lowest? Yeah, so now you should let me know if that works for you. It should work now.
It did.
Okay, awesome. All right, so if we come here, so what was the lowest production in 2022? And we run this chunk here. You know, we can see that. So right now it is, I guess we showed a few different ways of extracting, like of arranging your data, I guess. So you can see from low to high or from high to low, or if you wanted to extract just the lowest number, so a single row instead of the full data arranged. We also saw that as far as using a filter and then getting the maximum value of a column or the lowest. We also saw that. So here what we're seeing is that the lowest production in 2022 was County Marion with 0.03 million bushels in 2022, right? So this would be our answer. And I do want to point out again to you, we're going to have a mini project maybe on Monday that I'm going to introduce that is basically going to give you a different data set, and you're going to have to answer some questions just like we're doing here. In that case, and I will provide these instructions in more detail when we get to that point. But you know, if I'm asking you on an assignment, in this case, a mini project, what was the lowest production in 2022, and you just show me a table, that is not going to be enough. You have to show me the table and also at least write a sentence saying the lowest production 2022 was County X with Y amount of production. So we have to at least write a sentence there to explain or to fully answer the question. Just providing the output is not enough. Okay, so if someone was not able to run this last chunk that we produced last class, please speak up, because if you were not able to, you're not going to be able to follow the remaining of the class. All right, I don't hear anything, so let's keep moving. The next chunk here, I'm asking to plot production over time for the lowest producing county in 2022. We kind of did the same like just previously when we're doing for the highest producing county. So we kind of already have an understanding of how we would translate that question into code. But I do want us to kind of think through this again. You know, there are times in this class where I'm going to be coding myself and kind of telling you what I'm doing, and you're going to be, you know, following along, especially the first times that we do something new. However, if we have already done something, you know, I could just come here and type myself, but the goal is for you to understand and for you to start thinking about how can you transform these, you know, questions, these spoken questions into code language. All right, so, you know, just think about, I'm just going to run soy.w so you can see what soy.w is again. So for just a refresher, it has almost 6,000 rows and 4 columns. The columns are year, county, and production in bushels and production in million bushels. And we have for all counties since 1960 in this case. So a very large data set. So if I'm asking you this, plot production over time for the lowest producing county in 2022, and knowing that we just learned what was the lowest producing county from the chunk above, what would you do here? I'm going to ask a few people line by line. So then what would be the next immediate step here? Neva, what do you think? Okay, so filter, yes. Okay, county equal because it's a Boolean operator. And then quotation marks. And then Marion. Yes, I agree. I think that's going to work. Right, so that would be the first step because Marion was the lowest producing county in 2022. So we just want to keep the data for that county. Thanks, Neva. If we run that, you know, out of the almost 6,000 data rows, now we're left with only 51 because it's just the data related to County Marion. And now it has all the years there, right? Okay, I think that this is basically the only, like on the data side, the only thing we have to do. So now I guess we're ready to start plotting this. So let me add a pipe. And I'm going to start a ggplot here. If you recall, the pipe makes everything on its left as the input of the next function, and the input of the next function normally is a data set. So it's kind of implied that data set is getting into the data argument in ggplot. We don't give it. We can just go ahead and type the AES function. If you remember, when we're setting the x-axis variable, y-axis variable, color, fill, shape, anything like that, it's going to have to be within the AES function. Okay, so thinking about our question again, what do you think should go on X? What do you think should go on Y? Which one?
Production million bushel on X, on Y.
Okay. So Y, awesome, I agree. So Y is production million bushels. On X is going to be year. Yep. So just as a reminder again, if we stop at this stage, R is going to do exactly what we asked it to do. It's going to put year on the x-axis, production on the y-axis. But it didn't show us any data yet, and that's because we just didn't ask it to show any data quite yet. So the next step here is going to be to ask it to add a geometry to show this data for us. So I'm going to add a plus, hit return, and we need to specify a geom. I do want to propose myself here. So we could use geom points, we could use geom bar, but because it is x-axis is time, I think having a line is more helpful. So let's go ahead and do geom_line and just look at that. Okay, so here we have production of Marion County over time, given that Marion was one of the lowest producing, or was the lowest producing county in 2022. Right, so if we look here, look closely, at least on the y-axis, we see that's, I think the maximum here is probably 0.12 million bushels at any given point. So Marion, the most Marion County produced over time was about 0.12 million, and that was in the mid-80s. And just for comparison purposes, if we come here and just plot again what we did with the highest producing county highest producing in 2022, right? That was Brooks County. We see that Brooks County was way above over time that 0.1 threshold, right? And got to almost 1 million bushels in early 80s. So it's definitely producing a lot more. And of course, the scale here is kind of giving you a range that makes sense for the data you're asking to plot. But if we were to plot those two lines together, we would see Marion really low here if compared to Brooks. Okay, so actually, in fact, why don't we do that for these two counties? So why don't we just make that plot for these two counties together so we can compare them and kind of say in 2022, this was the lowest, it was the highest, and this is how they behave historically in soybean production. All right, so we're gonna have to do something a little bit different here. So, we're still gonna have to filter, right? So if my goal is to show the same plot, those two lines, I have to keep those two counties. So we'll filter county again, like we were doing. But now because I'm gonna filter two counties, so every time you filter one value, so county equals to this name, we use equal. However, if we have two or more values, using equal is not gonna work. So we can try that. So let's say I would say county equals to, we would have to use the C function to concatenate two values. So I would say here, so the first one was Brooks, and the second one was Marion. So let's include here Brooks first. Don't forget the quotation marks, and then Marion second. If I do this, let's see. I don't know if it worked because before we had here for each one, I just want to inspect how many data rows we had. So we have 51 just for Marion, and we had 62 for Brooks. So we should have 51 plus 62 should be the resulting number of rows of this query. And it's giving us 53 back. So it's doing something, it's giving us something, but it's not correct. And the reason for it is just a difference in syntax. So whenever you're doing a filter that you're asking for more than one value of that column, instead of using equal sign, we use percents in percents. It's just the way that we specify this, and it's just saying, if Brooks or Marion are in county, filter them. So when we apply this filter correct now, we should end up with, 113 rows, which is what we would expect because it's all the rows from Brooks, all the rows from Marion. That's what we would expect. All right, so let's come here, add a pipe, and let's begin our ggplot. To tell you the truth, I think what we can do is you can just come on the code on the chunk above and just copy starting on ggplot. You can just copy that part and we can just paste that here because that part of the code is the same. All right, so let's run this and see what we get. Okay. This looks weird, right? What is going on here? Anyone has any guesses?
Cycle
Say that again?
They add values together.
Yeah. So basically, so Doug said here that it is just added the values together. So I mean, it didn't add in the sense of like sum, but it basically took each one of the points for both and connected all the points, right? So it doesn't know yet that we want to color or to, well, I guess it just gave it away, that we want to plot differently those two data from those two different types or those two counties. What would you change here? How would you change here in this code if you wanted to say, I want, let's say, color to change according to county? Where in this code would you make that change? Sundas, what do you think?
Already.
Okay, nice. So why here? Why not here? So my question is like, why did I say color equals county inside of AS? Why not outside? Do you remember? Let's try both. So maybe let's try the one outside and see what happens. Really, nothing happened and it didn't give us an error, which I was surprised. I thought it was going to give us an error. So when we say any of these like color, fill, shape, size, transparency, if we say that outside of AES, we need to give it one fixed value, right? So let's say I want the lines to be red. I will come here and say red. Oops, you know what? Sorry, I'm actually in the wrong place. I'm at the ggplot. I needed to have this inside a geom line because that's what it would understand. So if I have color equals red at the geom line, it would change all that color to the color I'm asking for. However, if I want to, and this is really important, a really important concept that I want you to understand. If I want to map a plot aesthetics in the sense of color, fill, shape, size, transparency to a column. So I have a column here that I want to map to a aesthetics. It has to be inside of that AES function. So yes, Sandas, you are correct. I just wanted to make sure that we're thinking through these differences. So if I come here inside of the AES function and I say color equals to county, it's going to do what we are wishing, right? So look at that. Look just how massively more important Brooks is compared to Marion over time. Not just in 2022, Brooks was the highest and Marion was the lowest. But if we look historically, you know, maybe they were not the highest and lowest every single year, but you can really see how Brooks County has been producing a lot more soybeans over time than Marion, even when times were lower, like around the 2000s here. And this is also something interesting because, you know, and maybe not just apply to this, but apply to any plot that you look at. When we're looking at them separately, at those plots separately, it almost, you know, if you don't pay close attention to the y-axis, you don't really realize this difference. It's only when you bring them together that we really can tell that difference. Right? Awesome. All right. So let's think about here on our next question, which is plot the state total production on each year. Now, I want us just to take a moment here and think about this question. So we have already plotted in the past the county, so the average production on a county basis per year. And I want to go back to that plot just to show you again. Let's see, I think it was production, latest year reported. Yeah, so it was right here, right? So here we group by year, and then we took the mean production, which is in a county level, right? So I'm basically saying of all these counties, I'm taking the mean of their production, which is different from their sum. If I were to make a sum here, I would know the total production at the state level. If I'm getting the mean, I'm just seeing what's the mean across all of these counties. And that is also reflected on on the y-axis values. So if you see here, the peak mean county production in a given year was probably about 0.5 million bushels, right? Which is really, I mean, it's the average of all counties on that year, right? Now my question is a little bit different. Let me just browse that again. So I'm asking, plot the state total production on each year. So it's a little bit different, right? So let's start thinking here and developing the thinking of how we translate the answer to this into a code. I want to add a pipe here, and I want to ask, so thinking about plot the state total production on each year. Brittany, Lisa, what do you think we have to do next year? No, nothing. So, well, let me ask Doug. What do you think, Doug? What do you think we should do next year to answer this question?
We're gonna have to combine each.
Okay. Okay, I like it. I like it. So I like that you like, and I would really want you all to be doing this as well. I'm sure you are all doing this. Like if you start thinking in the issue in as you would normally, and then we try to translate whatever we think into code. So, okay, Regimar said need a group by year. Yes, you got it, Regimar. So the next step here, the immediate next step, which is also going back to what you said, Doug, we need to combine these years somehow, or combine the data within years somehow, and that we do that using a group by. So if you go ahead and do group by year, that is the immediate next step. If you recall, group by itself doesn't do anything. It's just creating those groups for you, and now you can apply a function to extract some information from those groups. So I add a pipe here, and I need to do something else after. Let me see someone else online, if somebody can help me. Kumar, what do you think? What do you think we have to do next?
I think once I think we can like sum the counties together, like sum the values of all counties per year.
Yes, you're on the right track. So how do we do that? What function do we use for that?
We can use summarize sum.
Okay, so we have to use the function summarize because that's what's going to apply some summary function to the data, right? So we do start with summarize. So let's go ahead and call the column of whatever we're doing. Let's call that total prod. We say equal to, and then, you know, I don't think we've seen this function yet, but remember I was telling you that within summarize, you can extract the mean, the median, minimum, maximum, standard deviation, coefficient of variation, and sum. Sum is also one of those statistical functions that we can apply here. So let's apply the sum of which column. So let me just print soy W here. Which of these columns would be one the sum of? Rolando.
County?
Okay, so you said county. Let's see what Rolando has to say.
I was gonna say production bushels or million bushels.
Yes, that's exactly it. Thanks, Rolando. And I want to make this distinction again because this can be confusing. And I just want you all to have this very clear. When we want to extract a statistical summarizing variable from data, we have to first set the grouping level, which we do with the function group by, and then we say, what is that grouping column? So in this case, year. And then on the summarize function that we use following that, within here, so we're doing the sum of something. If we did sum of county, it would not even work because county is character. You cannot sum characters. It wouldn't work. And even if we said sum of year, I guess it would work because year is numerical. So that would work, but it's not what we're looking for. And I'm sure you would realize that once you run the code and you see it. But remember that within the group by is where we determine the groups, and within summarize is where we say which column has the values that we want to summarize for those groups, right? Which in this case, production million bushels. All right, so if we run this, I just want to run that to show you. We get back 64 rows because there's probably, I'm assuming there are 64 ears in this data set, so 1 row per ear. And then we got the total production in million bushels, right? And look how the sum is basically taking all counties that had data reported for that year and summing them together, right? And now that makes sense because now we're looking at values like, even though it's still kind of low, but we're seeing like starting at 1.15 million bushels. That makes sense. If we were looking at the average, which we did the same code, but instead of sum, we did the mean. Just want to go back there. So this is we did the same thing, but we did the mean instead of the sum. Look at how the mean is really a lot lower than the sum, which does make sense. I hope that that you can make that connection, because here we're taking the average production across all counties, whereas the sum is showing me all of them summed together representing the state level production. Okay, I want to go back there to where we were. And now, I'm asking for us to plot this. So let's create a plot. So right after the summarize, we add the pipe to keep developing the code, hit return. We're going to use ggplot here as we've been doing. Now, within the AES function, I think really now we don't have too many options to choose from. So X is going to be ear, Y is going to be total prod, which is the column that we created through the summarize. And then let's just go ahead and add a plus and then ask for a geom line again. Let me show the code still in case you're still catching up while we also look at the outputs. So we can see now again that, as a state level production, Georgia soybeans were the golden era of soybeans in Georgia were again around the 1980s. Through the mid 1980s, where Georgia was producing over 60 million bushels of soybeans in a given year. That's a lot of soybeans, and especially when we compare to these days, right? So these days, Georgia is producing maybe 9 million bushels of soybeans compared to over 60. So definitely soybeans lost space in Georgia. We can see that on this type of data. Okay, so lastly, the last thing I have here for us is I want to make this plot. So we've been playing with ggplot a lot. ggplot has so many things that you can customize to make these plots look a lot nicer, a lot better. Especially, I guess any one of you would benefit from these skills, but especially if you are planning to publish a paper. Really nice put together publication ready figures make a difference in the quality of your work. So I really just want to take a little bit of our time here to do some customizations on the plot here. Let's see. So what I was doing, I basically want to take this plot that we just created above and just make it publication ready. In different ways. So to begin with, you can just go back to the previous chunk and copy that code because we're going to just further develop that on the chunk below here. So if you run at this point, it's going to be exactly the same as what we just did. And so let me ask you, I'm gonna, if you have the mindset of, okay, I'm gonna put this in my paper going to be published in whatever journal. Let's just be very forward thinking, and let's say we're publishing in Nature and want to make this figure really sharp. What would you change in this figure to make it publication ready?
Maybe make the line thicker
Okay.
and bit more space in the ears. I would like to add more ears, I guess.
Okay, awesome. I like that. So let's start with that. So Kumar said, make the line thicker. That is a very easy one. Here on geom line, we just say size equals to a given number. Maybe we can try, we can try 1. and see how that looks like. Already looks a little bit thicker. How does that look like, Kumar? Do you like that?
Yeah, it is better, yeah.
Okay. All
You
right,
can add color to it.
color. Okay. Maybe someone else wanna propose a different color for this line. Well, Kumar, I think others may not have an option, so, or may not have an idea right now. Do you want to propose a color?
Go with blue or red. Red would be more vibrant and visible.
Okay, so let's say color equals to open and close quotation marks red. I want to take a quick detour here just to tell you all, if you use color names, you can use that. So, right, it could be orange, it can be blue, whatever you type here will most likely be recognized as a color and work. I'm just gonna go back to red. But if you, the more you work in, especially in programming languages, you're gonna hear about this concept of color hex. So a color hex is a I think six digits code that we can refer to colors. I want to make a quick hook here and show you. So there is, if you just type on Google R colors, there's going to be a lot of stuff that we can use. I normally go to this first, resource that has a list of all colors and their names. So this is not hex, this is the names, and there's a whole list there. So if you type any of these names here in R, it's going to know that color is what you're referring to. So we're not going to spend a lot of time here. But I also want to show you, if we wanted to be UGA dogs proud and we wanted to use the UGA red instead. So if you go, we just Google like UGA colors hex, every university has a team within that university that sets these patterns. So the UGA red is a very specific type of red. So this is the hex color for that. And this is coming from, I guess it's not the UGA website, but they're probably getting this information from a UGA website. So this is the hex code for the UGA red. I just want to copy that. You don't have to find this website right now. You can just copy the value. And let's just use that value in our plot instead. So we're UGA red proud here. So the code for that, and notice that if you're given a hex code, it has to start with a hashtag symbol. And then it's capital letters BA0C2F. That's the hex code for UGA red. Okay, awesome. So Kumar, you said something else that I want to build off of it. So Kumar was saying that he would like to see more ears showing on the x-axis breaks here. So right now is doing every 20 years. He wanted to see more frequently than that. One thing that the way that we would change that is if we just add a plus here after this geom line, there is a function called scale underscore. There's going to be a lot of stuff if you just type scale underscore. You can explore this later if you wish. But because we want to change the x-axis, it's going to be scale underscore x underscore. And then we see that even within that, there are different options. In our case, because ear is a continuous variable, we would use scale underscore x underscore continuous. And if your cursor is inside that function and hit tab, it's going to show you all of the arguments that it has. We're not going to explore all of them now, but I just want to show you that to change the breaks, we need to use this breaks function here. So this is where we're going to change the breaks or the frequency of those breaks on the x-axis. What we could do, so let's say, from 1960 to 2020, let's say that for some reason, I just wanted to show two values. I would use the C function. And because ear is numerical, I do not need the quotation marks. I can just say, let's say I want to show 1980 and 2020. If I run that, it does what I asked, right? It only shows the breaks for those 2 years. However, let's say that you do want to show, I don't know, eight years here. It would be a little bit more work for you to decide which are the breaks that you want to show and then add 6 numbers to this C function. Instead of that, I want to show you an alternative. So if you just delete that C function, and as you're doing that, you may also delete the last closing parentheses, just as a note. If that happens, make sure you type that back again. So we're closing that scale X continuous function parentheses. So there is a function called seq, I guess, for sequence. So the way that this function works is you give the starting value, you give it the ending value, and you give what's the interval you want to sequence for those numbers. So let's say that we're seeing here, or I guess we were seeing on the previous plots, that our data was starting around 1960. So we can use 1960 as the starting value, give it a comma, and it was ending in 2022. So we can just go ahead and give it a 2022 here. And you add a comma, and then the last thing you do is you give it what is the interval that you want your breaks for. It could be every year, it could be every 5, every 10. It's up to us. I want to propose that we use 10 as our interval. So for each 10 years is going to have a break in our x-axis. And if you run it, it should apply that change, right? So now we're seeing every 10 years, there is a break on your x-axis. You can do the same thing for your x-axis if you wish. The only difference is that it would be scale underscore y underscore continuous. And of course, then it would be values between 0 and 60 instead of 19s and 2000s. Okay, and just as just want to show you also the concept here. So this function seq is not a ggplot specific function, right? So if you just run that part of the code, that seq part of the code is going to give you that sequence. So you can use this in any context. We're just using that as a helper function for us to provide the breaks that we want in ggplots. Okay, so we changed the line a little bit. We changed the tick breaks on the x-axis. What else we need to change that it's very evident that to make this publication ready? What? The title? Okay, so we can change the title. So before we change the title though, I mean, the title, we could give it a title, but I think there's something kind of related to it that would be more important at this point. The legends, right? The name of our axis here, the axis titles. So right now they're under or lower score. And you know, it's not how we would publish it. So let's add a plus here. In ggplot, we have this function called labs for labels that it has arguments like X, Y, title, subtitle, color, fill. We're not going to export all of them today, but if I want to change the x-axis title, I say X equals to, and then open and close quotation marks and just give it a name. I want to give it a name year. So if we run that, we see that that change was reflected there. I'm going back to that labs function, give it a comma, and I want to change the y-axis label as well. I'm going to say y equals to, open and close quotation marks. So now we're going to have to provide a unit as well, right? Because just saying total production is not going to be enough. So let's say total production, and then here you open and close quote or parentheses, and this is like million bushels. Right. So looking better. I mean, we could keep going and customizing this in many other different ways. I think for now I'm okay with this. I think it's a good stopping point for us at this point. But I really, this was just to illustrate the concept of how ggplot works, right? It is incremental. So each function you're adding is changing something about this plot and is making small changes sequentially here. So we could keep going and changing many other things, but I think for now, I'm happy. Okay, so really, I guess the true last thing that for some reason this script here doesn't have, maybe I accidentally deleted it, is I want to export soyw. So really soyw is the one that we created way above. We were just exploring soyw at this point. But I want to export that to file. I want to save soyw to file because on the next exercise, we're actually going to be importing soyw again. So if we do not export this to file, we're gonna have to come back to the script to run it all again, so it is in our environment, then we can use it. Which I want to avoid that. I wanna, we brought soy, we made it clean and wrangled and ready for analysis, and now I want to save it to file so we can use it for a different script. What I want to propose here is if you add a hashtag and you type, I just wanna type exporting, so we create that level of indentation in our table of contents. Let's create a new chunk. I don't think I've shown you how to create a chunk yet, because I've been giving you the chunks we're using. There is this +C icon right there, that if you click on it, it's gonna create a chunk for you. I normally, there's a keyboard shortcut that at least on Macs is Option Control I. Yeah, so Option Control I in a Mac also creates a chunk. That's what I do most of the time. But if you don't know the shortcut or you don't want to use it, you can always use that button right there to create a new chunk. Okay, so something to notice as well. soy_w is just an object, right? It's not CSV, it's not Excel, it's just an object that has a data frame in it. Now I want to export this to file, which I have to give it an extension. So I have to make a decision of what type of file I want to save this as. I want to save as CSV, and every time you're writing to file, think of the function write. So there is a write.csv, there is a write_CSV if you load a tidyverse. You can use either one of them. I think they both work. I want to use the write_CSV, but the .csv should work just as fine. The first thing we give it here is the object that we are exporting. So that's soy_w. Let's give it a comma and break the code. And now we give it the path. Because it is a path, we give that quotation marks. You have your cursor blinking in between that. And if you hit tab, I mean, you don't have to hit tab right now, but if you were to hit tab here, it would just populate the name of the script because it sees that you are inside the code folder. We want to go on the output folder. So we have to go out level up, .. If you hit tab now, you are the main directory of this project. I want you to navigate to output. And now we need to give this a name. The way I want to call this object is soybeans_NASS_processed. And because I am exporting as a CSV, I just say .csv. So when we run this piece of code, if you had an error in your code, it may give you an error, but if it worked all right, it's not going to give you anything. But we can come back here on the Files tab, click on the R blue button to go to the home folder and navigate to the output folder. You should be seeing now your soybeans NASS process right there as a CSV file. And this is also in your computer folder system, right? It's not just in our studio. It is actually a file in your computer right now. So we took that object that at that point was not a CSV. There's no such thing as a CSV object. It was just an object that was a data frame type, and then we exported that to file and saved as a CSV. Okay, I think this is a good stopping point for today. Next, so on Monday, we're going to be importing the soybeans NASS process and doing maps with it, doing a lot of cool plots to look at this data in a spatial context, which is going to set the stage for you on how to work with spatial data in R, which then becomes the main point after that, because everything we're going to be doing is going to be spatial after that point. So it's just to give us a light introduction into geospatial data in R. Okay, I'm gonna get our attendance for today on GitHub. So I'm going on GitHub on our class directory, creating an issue for today's attendance. Wait, January 18th, 26. All right, so the issue is open. Please make sure you claim your attendance before taking off. And that's all I had for today. If anyone has any questions, I can hang around for a couple minutes. And if not,
I have a question.
Okay.
I have a question.
Yeah.
So on the exporting, So I went out to create a chunk to insert a new code chunk.
Mhm.
All right, and that, so it gave me the R, and it's an I wrote that one, but when I run it, it just gave me error in file I false open. So
Okay,
that's
I
what I
think,
get.
did you type soy W here? Because first we say what is the object that we want to export, and then we give it the path.
Yes, I did.
Okay, so there may be something going on with your path. Maybe let's do this. I have a couple minutes that we can, or we can meet for once I get back to my office, and then I can help you on Zoom just on a one-on-one. Is that okay?
Yeah.
All right. So if you actually can, if you can go ahead and create that Zoom link and send to me, I'll jump in as soon as I get to into my office.
Sounds good.
All right.
Thank you.
Sounds good. See you soon. All right, everyone. Thanks so much, and I'll see you on Monday.